Welcome everyone, Lonnie Payne back here with a pinball video, reminding you if you like what you see, please like, subscribe, share. Let's get started.
Welcome to the jungle. We got fun and games.
In today's video, I'm going to talk about some repair techniques and things I use to help diagnose problems in a pinball machine. I know it gets frustrating when you're playing a pinball machine, something happens, and especially if you're new to the hobby, trying to figure out what's going on with that. So I'm going to show you some of the tools I use and some of the basics behind what can go wrong in a pinball machine. If you watch my equipment video, you see the test kit I use to repair. I'm going to elaborate on some of the little accessories to that test kit that you can actually use in the machine itself to kind of show you exactly how you can tell if something's going on the board or in the machine itself. And if you're ready, we'll get going. Okay, for today's video I'm going to be using the F14 Tomcat System 11. And for most of what we talk about today can be used on other types of machines. The philosophy is all the same. It just may work a little bit different in the circuit boards for each machine, but there's three main parts of a pinball machine. You got lights, you got switches, and you got solenoids. And the combination of all that is what makes a pinball machine work. Now the lights and switches are very similar in the fact that they use what's called a switch matrix. So you have 8 columns, 8 rows, and the combination of that gives you 64 possible switches, 64 possible lamps. Now each pinball machine may not use all of those, but that's what it's capable of. Now that presents some issues. If you have a single switch or single lamps gone bad, it probably has to do with that particular switch or lamp, because when it's normally in the board, you lose a whole column or a whole row. And you can look at that in the machine and kind of diagnose, hey, this switch isn't working. You know, all these switches, when you look at the switch matrix in the manual, you may realize all those are in a row or all those are in a column. Now, that's not 100% that it's in the board, and I'll talk about that when we get to testing. But as a general rule, if you have less than 8 switches or 8 lights that are malfunctioning, it's probably not a lamp or switch matrix issue. And the reason they use matrix is it keeps the wiring down, so you don't have dedicated wires going to each particular switch. They can daisy chain them, and it's a little bit easier. Now the solenoids are all direct wired. You know, they each have a negative ground and power, so one of them can malfunction, and it can be the board, and we'll talk about that. Okay, so these are the items that I'm going to use to diagnose today. This is a switch matrix board, which can simulate every switch in a pinball machine. You can see there's actually 64 of them. There's columns and rows just like there are in the switch matrix. When you look in the matrix diagram, this follows that exactly. On the rows selection, you have the diodes, and then you have the column pins here. You're going to hook up these cables and then hook them to your board. And the way I designed this was I also have another cable that I can hook up to the end of this one that goes to a WPC, so I can actually use this in both boards without having to create a whole new cable for it. And so we'll use this to actually test any switches that we want to test. This is the lamp matrix board. I actually had one that I built myself a couple years ago that worked great, but then I decided to buy this one. This is actually from Siegecraft Electronics because it's a little bit more compact and very nice board. He sells several of these types of things on his website. It's the same thing, plug it in and then plug it to each of the 2 pins on the board, and that's actually 64 lamps in that matrix that will show you if any particular lamp row column. It's very easy to tell by plugging this in. And then for the solenoids, there's actually 2 regular solenoid hookups and then 1 special solenoid. So we'll hook all those up, and basically when the solenoid's firing, you'll see the little red light. Now this one actually, these I built myself, but once again Siegecraft sells something very similar to this. You need 5 volts to run it, so here's the 5 volt power. And you can see it's daisy chained to a pin, so each one of these can plug into each other to get the 5 volt power. And then it has to run through a 100 ohm resistor to power that down, to power these LEDs. Then this plugs into your plug that provides the negative ground, which completes the circuit, makes the light up. So now that's kind of a general rule. And here's the special solenoid test. You plug this into the special solenoid section, which not all boards have. You select the solenoid via the dip switch, push the button, it fires the solenoid. You can kind of see how if that system's working. So those are the basic components of what I'm going to do, or what I'm going to use today, and we'll hook them up and show you how to test this thing. Okay, I got everything set up here, and just one thing to note, when you're testing something, normally one thing is wrong, so you would have one of these things hooked up. You'd either have the switch matrix hooked up, the lamp matrix hooked up, or one of the solenoids hooked up. You wouldn't have them all hooked up, so this is a little bit of an extreme situation, and I'll have to make adjustments when I test because of this. But anyways, I want to show you all of what is done. So you've got the switch matrix hooked up to the plugs, you've got the lamp matrix hooked up, and then you've got the main solenoids hooked up here and here, and then you've got the special solenoids hooked up, and then the actual controller for the special solenoids ready to go there. What you can already see the lamp matrix. And one other thing is, when I build these, I put something on the back of them so there's no chance that anything will hit anything metal, start shorting stuff out. So every one of these things has something on the back of it, so it doesn't matter where it lays or sits, it's not going to short out anything. So just a note there. So you can already tell, looking at the lamp matrix, every lamp, is working. And so if this wasn't working, what you would end up seeing is one of these rows or columns completely out. But every light's working on this one. And so if we wanted to go test the lamps individually, and one thing I'll back up and say is I kind of try and divide the problems up between board and machine. And that basically happens at the plug. And so the one situation, and I've had this happen several times, where you have a whole row or column of lights or switches out and you immediately think it's the board. What can happen is this plug itself can be bad, and the connection on one pin might be bad, so the entire row or column appears that it doesn't work, but the board's fine, everything's fine. It's just you have to replace that plug. And normally you can tell if you jiggle the plug a little bit, unplug it, plug it back in, it might start working. The problem is it's eventually going to fail, so you'll end up wanting to replace. Usually I replace the header pins and the plug on that particular plug. So that's the one situation where it can make you think it's something, but it's actually something else. So that's just something to be aware of. So if we want to test each lamp individually, you can just go into the test or diagnostics and then go over to the... Okay, next thing we'll test is the solenoids. And we'll start out with the out hole. That's number one on the list, and you'll see that it's flashing there. Now, because these have 10 lamps in them, the first one's not active, so that's actually the first active lamp there. So don't worry about that first one's not showing up. The thing about solenoids is they have an A channel and a C channel. The A channel is the actual solenoid itself. The C channel is a flasher that's associated with the same transistor. So it kind of saves, once again, some circuitry by allowing a transistor to switch between A and C and use the same circuitry. I'm actually refilming this. I wasn't happy with the way the lights showed up on the original film, so I turned some lights out. So hope the picture's still good enough for y'all to understand. We've got the out hole on, that's the A side, and you can see that the light's blinking. So if the coils were actually hooked up, that thing would be firing every second or so along with this light. Now when we activate the next one, which will be the C side of that, you see the same lights blinking, but you got the LED on here indicating the C side is on. So that's how it triggers two different things using the same transistor. It switches, sends the power to the flashes, or it sends the power to the coils. On the bottom of the playfield of System 11 boards, you actually have flasher boards. So if you have a flasher problem, it could be down on the bottom of the board too. And they're actually scattered out throughout the bottom of the playfield. And so you might want to check those boards, the little green boards, very easy to see. I may show those later, to where you might have a wire that popped off or something. So you might have a flasher board problem if these things all indicate good. So these are the flasher boards on a System 11. Not all games, non-System 11 may not use these, but since I'm doing a System 11, thought I'd go ahead and show it to you. And so the power comes in when that C channel is active, and then the output goes to the flasher. So if you have a flasher not working, but when you test the plugs up there, things seem to work, come down and find the particular flasher board, and it may take a little bit to investigate which one's which, and you might find a wire popped off. I've had that happen before. And the thing about it is not all of them are used. I think you can put up 2 different flash sequences on a board, and if you don't use them all, you may have a board that doesn't have one. So if you actually have a broken resistor and you can't have, or you don't have the parts to fix it, you can actually maybe swap some boards out to one that doesn't use that channel and get it fixed that way. But that's how the flasher system works, besides the plugs on the board themselves. So we can cycle through all these. So there's number 2, and there's its associated C with both of them indicating. There's 3, spare 4, it's not used in this game, but flasher 4 was. Like I said, the first 8 of them uses AC logic. Then when you switch to 9, what you see is the first indicator on this side. Now they're just going to be dedicated solenoid lines. So 9, 10, 11, 12, 13, 14, 15, and then 16. And then it's going to go to the special solenoids, which are over on this bank. You can see that they'll go through their test. And so you don't need that special solenoid tester all the time, but I'll show you how it works. If we've got that plugged in now, and we can actually select through the dip switches, one is active, and when I hit this button, it'll test it. So there it is right there. So, you know, you can have the game up and put this in there and test it, like say with the game running, and you don't have to go through the test menu. You can actually test those special solenoids that way. So that's how that works. And you can here's the ground for it. Just goes to the ground, and I forgot to show you the 5-volt wire comes out to here, and then this one feeds to there, and then this one feeds over here. So all 3 of these are using that 5-volt lamp from here. They're just piggybacked on each other. And then to test the switches, like I said, this is a switch matrix 1 through 64. So you can just go through, and it's just, if you read it just like the switch matrix in the chart itself, and you can test every single switch and see if something's not working. And so that's kind of the basics of how these little things work and how you can actually put them in a machine, and I can test to see if something's wrong. Now say you have 3 or 4 switches that aren't working, and you put this switch matrix up here, and all those switches are working on here. Well, that means the board is fine, and what's probably happened is you've had a wire that has come loose between 2 switches, and then everything in that switch matrix or column or row after that won't work. And that's another thing, is you plug this in. If this wire comes off of the very first switch in that matrix, you can have the whole column or row go out, and you might think it's the board. You put this thing in there, and boom, you can test it right now. Just like if there's a column of lights out, same thing. You plug this thing in, and all these lights are working. You don't have to worry about the board. Now you got to go to the machine itself and start looking for those problems. Now just to show you kind of what can happen when you look at the switch matrix and the lamp matrix, you can see the transistors and stuff up here and through here. Normally when you have a matrix problem, whether it's a column or row, it's normally a transistor that has failed, and it cuts that entire row or column out. And so you've got these transistors here for the lamp matrix, then you've got these transistors here for the switch matrix, and then you've got all the little transistors here that'll do the coils. And normally when you have one go wrong, like say for instance this one was bad, you want to replace the big transistor and just go ahead and replace the little transistor as well, because a lot of times if you replace one, the other will end up failing eventually anyways. You need to replace both of them. And you know, they're a little bit different. Tip 102s I think is one of the more common ones, and just the manual is pretty easy to read as far as which transistor is what, and the little ones are all a little different on some of them. You know, just read the transistor itself too will give you, you know, a good indication of what it is, and then follow it up with the manual. And so basically if you watched my equipment video and saw my System 11 test kit. This is exactly how I use that test kit, except this board would be on my bench, but all of these things would be hooked up to it just like it is now, and I can actually work on the board on the bench and do all this testing before I bring it back. So if the board itself has, say, multiple problems, I can actually take it, work on it, continue to work on it, and then once I can go through every test, and when I'm working on the board, that's normally what I do, is I hook everything up and I go through every single switch, every single coil, every single lamp, make sure everything is working like it's supposed to, then I come bring it back into the machine, plug everything back up, and good to go from that point. But anyways, I just wanted to kind of show you how I test these things and how each of these things use. And like I said, if you had one coil on here that was bad, you might only have this one hooked up and that's it. And you can go through the testing, try and isolate whether it's in the board, whether you need to start tracing wires. But I wanted to hook all of it up and just kind of show you how it works, and hopefully that makes sense. And obviously I'll be able to answer any questions y'all have if I didn't cover something. All right, now I've showed you how to test. All right, so I've showed you how to test the machine using the little accessories that I have. Now I'm going to teach you a little more of just the old-fashioned way of testing that you can do if you don't have any of those things or don't want to get any of those things. What I built here is a little clip and a little header pin. You can see it's pretty easy. You can use alligator clips. I tend to like to use these a little bit better. And these really come in handy when you're testing solenoids. Like I said with the lamp matrix and the switch matrix, sometimes it's easier to see what's going on because there can be multiple failures if it's a board problem, whereas it might be a single failure. It's more of a playfield problem. The solenoids, you're probably just going to have one fail at a time, and so it's harder to know if it's the board or the machine. Now I'll say this. If you have multiple solenoids fail, you want to check a fuse. If you have a solenoid that locks on, it's eventually going to blow a fuse, which will make several solenoids not work. Now what you want to be careful of, turn the machine off, replace the fuse, but be ready to figure out what's going on when you turn the machine on, because if that's in fact what's happening, the second you turn the machine on, you're going to have a coil locked on. And if you don't either turn it off real quick, figure it out which one it is, turn it off, you're going to blow that fuse again. So if you have multiple coils failed, it's probably a fuse, which means you have something wrong in the board. And you can trace which coil it was if you don't obviously see it in the machine. Okay, so say we have the shooter lane feeder coil is not working. So the ball's not coming out in the shooter lane, but everything else seems to be working. So that coil that fires the ball out in the shooter lane is actually the number 3 pin right here. So we know the number 1 pin is working. That is the out hole kicker. So what we can do for testing, we can put this little pin on here. All right, so just so we kind of go through what we were talking about, I'll go ahead and hook it up like it's supposed to be hooked up. So pin 1 into pin 1 in the plug, and then we'll go to the solenoid test. All right, so you can hear the coil, the out hole firing. So if we want to test the 3rd pin, which is that coil that fires it out, that's the one that's not working right now. If you put this in there and it fires, which it just did, you can hear it firing. So what you've done is you've verified everything from this pin all the way down to the machine. So we know it's not in the machine itself. It's got to be in the board. And you can verify that by switching this to the number 3 pin, putting this pin back in the number 1 hole, and if the board isn't bad, it won't fire. In fact, you can go through any pin in there and it won't fire. So by using this little jumper, you can actually figure out which coil's working, which coil's not working, and if it's the board or somewhere in the wiring, say a diode on a coil or something like that, or a loose wire, you can figure that out. So if we know number 1 coil's working, we can actually just go down the row of all these pins You can hear all them coils. So you can actually go through every plug on here knowing which one works, which one doesn't. And the same thing, if you find a pin in here that doesn't work, it doesn't matter which hole you stick it in there, it won't work. So by the combination of those two methods, you can figure out if it's malfunctioning in the machine itself or if the board's malfunctioning. To a lesser extent, you can do the same thing with the lamp matrix. You can actually go through with your little jumper cable and actually test each one of these. You can pull one of the lamp off, and then you can make sure you get one of the pins that's working, and you can actually stick it in each one of those pins. Even though it's, say, row 1, you can use that row 1 signal to test every single row, and same with the column. So like I said, there's a few ways to do this. I like using the accessories that I showed you just because it's very easy to use. Now the only drawback to using this method right here with the wires is it has to be in the machine, whereas if you take it out of the machine and have like a test kit you work with, you can actually use the lamps and lights to help you. So anyway, there's two different methods there, using the jumpers and then using the accessories to show you kind of how to test. This is kind of a basic test, but for all the main problems you have in a pinball machine, this is going to cover a lot of it. And just remember, if you have a fuse blown, there's a chance you just had a fuse blow. Sometimes that happens. But a lot of times what will happen is a coil has locked on at some point. You didn't catch it, whether it was in a game or something, and it blew the fuse and a bunch of coils aren't working. When that happens, one of these transistors has likely shorted and is putting a constant signal out. And so as soon as power is on the machine, it puts out that signal to fire that coil, and that coil will stay on until it and blow that fuse. So you just have to be ready when you turn the machine on after you replace that fuse to get ready to turn it back off once you figure out which coil is locking on. But if it's just a coil that's not working, then you should be able to use this jumper technique to figure out which coil it is and if it's in the machine itself or in the board. Hope you enjoyed the video. I know it wasn't super in-depth, but I kind of wanted just to touch the surface on troubleshooting the more common problems, and then some of the gotchas that might look like one thing but actually be something else. And the little accessories can make things so much easier. So I know I made most of those myself, but you can go to Siegecraft Electronics and they have almost everything just like that there that you can buy, and it's not that expensive, and really you do it one time and it pays for itself. So I highly recommend getting something like that to help you in your pinball fixing endeavors. If you like what you saw, please like, subscribe, share, and I'll see you on the next one.